Now we're going to look at a reflection and transmission of pulses from different interfaces. First, if you look at an incident pulse that is traveling to a fixed end, we find that this pulse will get reflected from this fixed end with the same amplitude and inverted. So if you look at the amplitude of this pulse, it will be the same amplitude in the reflected pulse, amplitude A, amplitude A. So the incident amplitude is equal to the reflected amplitude, but the pulse is inverted. If I look at a pulse traveling to a free end, then I will find that the pulse is reflected from the free end, but this time it is not inverted. However, the amplitude of the incident pulse and the amplitude of the reflected pulse will be the same again. Incident amplitude is equal to reflected amplitude. If the pulse travels from a light string to a heavy string, then we find that the pulse is going to partially reflect and partially transmit. The reflected portion will have an amplitude that is smaller than the transmitted portion. So the reflected amplitude here is A sub r. The transmitted amplitude here is A sub t. And we find that these two amplitudes are going to be smaller than the incident amplitude, AR and AT smaller than A incident, which is this amplitude of the incident pulse. So partial reflection, partial transmission. The reflected pulse is inverted, but it has lower amplitude. The transmitted pulse is not inverted, and it has a lower amplitude compared to the incident pulse. Now, if I look at a pulse that is traveling from the heavy string to the light string with an incident amplitude AI here, I will find that it will partially reflect and partially transmit, and the reflected pulse will have an amplitude smaller than the transmitted pulse, and the transmitted pulse is also coming out with a smaller amplitude, but it is also not reflected. So AR, AT, both less than the incident amplitude. So what do we mean by heavy and light strings? So if I find that the propagation velocity is high on a string, that means it's a light string compared to a heavy string where the propagation speed would be low. So you will find that here for this string A and string B, mu A is less than mu B. That's coming from light string to a heavy string. Propagation speed on A is greater than the propagation speed on B. So the reflected pulse propagates faster than the transmitted pulse. Here in this case, we have for string A and string B, mu A is greater than mu B, and therefore the propagation speed on A will be less than the propagation speed on B, because remember it's V is equal to square root T over mu. So these arguments about amplitudes, the incident amplitude is equal to the reflected amplitude for fixed and free ends, and for pulses traveling between light and heavy strings, the reflected and transmitted amplitudes are always smaller than the incident amplitude. They come from energy conservation arguments. So we will talk about how much energy is transported by these pulses or waves on these strings in the next video. So let's finish this by summarizing what we have found out. So if we have a fixed end implies the pulse is reflected with same amplitude and inverted. If it's a free end, the pulse is reflected same amplitude, not inverted. And why is a pulse inverted when it hits a fixed end? Because there will be a reaction force coming from the wall hitting on the pulse. The pulse is applying a force on the wall, and the wall is applying a reaction force on the pulse. So this comes from Newton's third law, action reaction. Now when a pulse comes from a light string and hits a heavy string, what do we observe? In this case, it's partially reflected partially transmitted and the reflected portion is inverted. Transmitted portion not inverted. And the amplitudes of the reflected and transmitted pulses are less than the incident amplitude. And if a pulse is traveling from a light to a heavy string, the propagation speed for the reflected pulse will be greater than the propagation speed of the transmitted pulse. And if the pulse comes from a heavy string and hits a light string, again it will be partially reflected and partially transmitted. None of these are inverted, so no inversion. And the reflected and transmitted pulses will have an amplitude smaller than the incident pulse. The reflected pulse, because it stays on the heavy string, is going to have a propagation speed less than the transmitted pulse. Okay, and once again, the amplitude arguments due to energy conservation. So basically the energy that is being transmitted by these pulses is related to the amplitude, and as we will find out, it's actually proportional to square of the amplitude of the pulse in the next video.